Welcome back, everyone, and thank you for coming again. This time we have Team Spann, who will be talking with us about Pulsar and its friends. Thank Tim to be part of PortECAP conference for this year. And if you have questions for Tim, please ask them on Umbrella. Go to the stream tab and ask those questions on the chat there. Tim, very welcome. If you can please introduce yourself, the stage is yours.
Sure. Thank you. Yeah, I'm very excited to be here. Really cool event. I'm Tim Spann. I'm a developer advocate at Stream Native. Stream Native is a company that's behind the open source Apache Pulsar. And today's talk is about how to get streaming data into data lake, database, wherever you need to get your data. We're going to do that with Apache Pulsar and some other open source tools that are available. And I'll walk through, why you might want to use our tools over some of the others and just how it works. Today, everybody has a lot of real-time data. It's not good enough to have data that's available in a couple hours or even a couple of minutes. And there's a lot behind that and a lot to make that work. I mean, today, most people have, some kind of hybrid or multi-cloud strategy. So you really need to be able to get this real-time data to sync up between different locations. You might have different availability zones. You might be in different countries, different regions of the world. Having to manually sync that data up is not something you want to do. Being able to work with microservices, at any developer conference, since I've been at Pivotal 6 years ago, microservices are the way to go. Being able to have small bits of code that work together but are not tightly bound together, very important. And have a way to quickly message between these, activate different microservices asynchronously. That's table stakes. Today, if you're not running on Kubernetes, it's going to be a problem. Fortunately, we have cloud native ways to run all these tools and to be able to get all your data and be able to figure out what's going on and being able to keep it in the stream for as long as you need, but not bothering other groups in your company, not have to worry about having, the names of things be ridiculous because you don't have any kind of segmentation or any way to separate different groups or applications within your company. Those are issues. Like I mentioned, Tim Spann, I've got a lot of content out there. So if you're looking to learn more about things like Apache Pulsar, Apache Flink, NiFi, streaming, IoT, I've got other presentations out there, other videos, code, all those sort of things out there. Again, the company I work for, maybe next year we'll be at a booth and we give out some cool swag. With the most of the original people who built Apache Pulsar over at Yahoo a number of years ago. And we try to make this the easiest way to do messaging and do streaming. And I'll tell you what I mean by that. It's a little different if you've heard of Kafka, you're at a RabbitMQ. Pulsar is a little different, and I'll show you why. Again, open source, very helpful. Things that make Pulsar very useful to most people out there. Things like multi-tenancy. What that means natively, it's very easy for us to segment how the streaming and messaging works because we have tenants, we have namespaces, and then your data is segmented into topics. So it makes it very easy for one cluster to be used by an entire organization or multiple organizations without having to worry about collisions of names, namespace security, everything is isolated. Scalability, when you look out there and you say, well, who's using Pulsar? Is it new? The size of the companies using it, we're talking companies on the scale of Tencent when they're putting entire chunks of infrastructure on there. So, scaling out from 1 or 2 nodes that support tens of thousands or millions of messages to places that are doing petabytes of data, billions of events a second. scaling out as big as you need to go. There's no theoretical top point, and we'll show you how the architecture supports that. Geo replication, as we mentioned, is just a simple configuration. And again, out of the box for open source. You don't have to buy some proprietary one to get that. Unified messaging, again, we'll dive into that one. It's kind of interesting. If you've looked in any of the other messaging systems, they have a way messages work. You either do it messaging style where you send messages, a lot of people get them, there's no ordering, doesn't matter. Or you do it streaming style, everything is in order matters. We do both. I'm going to show you how we do that. Durability, we have a separation between how we process the message and how it's stored, and the ability to have that automatically extended out into your cloud infrastructure, tiered storage into, S3 buckets or whatever. This lets you have the insurance that your data is stored and safe, and makes it cheaper for storage, makes it very easy to keep your data as much as you need. So you don't have to decide, okay, how much can I keep in a queue as a cache? You don't have to think that way. If you haven't heard of it, Pulsar has been around for a while and has a pretty rich ecosystem and has all the features that you might want from messaging or stream processing. And let's go around the loop. Messaging, things like change data capture, Debezium, those are there. Pulsar IO is all those pre-built components for you or ones you could extend yourself. Again, everything's open source, well documented if you want to write your own connectors. But the connectors are simple enough as, okay, point to a thing, have it stream data into Pulsar topics, or when data hits a topic, that event immediately goes out to, a sync, or you can configure it to go in some kind of micro batch. But, that's how you could instantly stream data to multiple places without having to write code. I can have data going to ClickHouse, going to S3, going to InfluxDB, going to MySQL, Postgres, and as many of those as you want, just as soon as that event hits the topic. Whatever language you like to develop in. I've been surprised that I've written really liking Golang, but the Java client is probably the first there. Really strong C++ one, Python, Node.js, Scala, Ruby. There's Haskell. There's a ton of them out there. There's also some connectors make it even easier. So you tell me, well, I don't like any of those languages. We've got, and I'll show you a demo today. It's got a native interface for WebSockets. So I could do it from a mobile app or a web app. Just send it through WebSocket API. We also support interactive queries with Presto Trino. That's built into the platform. So you could just run queries on anything in a topic while it's there. So you see what data is current there. And again, with that tiered storage and with the way we store the streams, it's very easy for you to store a lot of data. So it's not just, okay, maybe I have a few messages in the system now. It could be, petabytes of data. And that is a common use case through some of the larger companies. You might want to do stream processing or batch processing with Flink or Spark. Those connectors are very rich and native to the platform. As events come in, streams them in. With Flink, you have the Flink SQL catalog. All those topics, will look just like tables. You do whatever you do in tables, join them together, order by. That is a really powerful way to process your data, do event streaming, as it happens. But another feature to me that's similar to, say, a database trigger is Pulsar functions. And right now they're available that you can write in Golang, Python, or Java. More will be added eventually, but that gives you a pretty good set of things that you could put in there. They're tied to one or more topics and could do things like transformation, enrichment, routing, and send the data back to the same topic or to a different one. Makes it pretty easy. We mentioned that stream storage, so you could save these topics and events in cloud native storage. We also have in part of the infrastructure a low latency storage tied to this, but separate in Apache Bookkeeper. And we'll show you how that works. We mentioned there's different types of things you do with messages out there. The old school way, and still a very common way, is message queuing. Things like Rabbit, ActiveMQ, RocketMQ, SQS, MQ series, tons of these out there. They solve a lot of problems. It's usually a lot of messages, a lot of different clients reading them. Often used as a work queue, great way to call microservices, distribute data processing. We support this way of doing messaging. And we also have adapters out there for things like Rabbit and Rocket. So you could use their native connectivity as a way to talk to Pulsar. So you don't have to use a Pulsar client. I could use a Rabbit MQ library. I could use a Rocket MQ library. I could use an MQTT library. Lots of options there. And of course, data streaming, you've probably seen it in Kafka. If you know me from Cloudera, I was doing a bunch of Kafka there. Pulsar is very similar to Kafka, except for the fact that it supports message queuing and has a separation between compute and storage, as we like to do today in the cloud. But we support data streaming, ordered set of data where order matters. You do things like exactly once, at least once, often connected to things like Flink and Spark. We do that for you with Pulsar. And again, built natively for the cloud, multi-tenant system, decoupled architecture, a Geo Replication built in. So you get all the features that you like from, say, Rabbit, but being able to scale out to hundreds of nodes, process as much data as you could possibly do. Again, this scale of Pulsar has not hit a limit yet. The large use cases out there are massive. And again, you might not have heard of Pulsar, but it's been around. It originally was developed inside of Yahoo as their one messaging system to do things like Kafka does, but also do things like RabbitMQ, because you have multiple types of messaging in an organization, and it's nice to have everyone using one set of shared clusters. Gives you more uses for the messages, because sometimes you want it in a mobile app, but sometimes you also want, Flink to process it or to go to the data scientist somewhere, or also have it stored in the cloud. Having one open source project to do that, really important. Pulsar has really been drastically improving over the last couple of years here. Stream Native was founded to really push this forward. Like you see some of the names there, Tencent and Best Pay, really large users. We've got a lot of contributors. We do 3 conferences a year, Europe, Asia, and the US, and hopefully we'll have hybrid next year, as everyone's hoping for this event and most events, but we'll see. Exactly once semantics are in there, transactions, connectors to all the major things. And if you look at some of the people who helped us out on these various adapters for Pulsar, these are pretty big companies who had the need there. Pretty rich ecosystem out there. We run on almost all the major clouds, and the size of the customers out there, people like Flipkart and Applied Materials, are doing some pretty serious work there. Under the covers, it is a little complex, but that complexity is, handled for you. You don't really have to think about it, other than to know that separation between the brokers that handle your messages and the bookkeepers that store them gives you the ability to, if you have a lot of messages, I could scale up those brokers. If I want to add more storage, I can add another bookkeeper, or I could just add tiered storage and use, the very inexpensive S3 or other cloud storage wherever you happen to be running. Makes it pretty easy there. Those functions we mentioned. REST API for everything. So however you want to spin up, spin down things, all the Kubernetes drivers and operators, everything you might want to have at their Helm charts, all that's already been built. All that's in the open source, makes it pretty easy. There's also a command line interface for doing everything. So if you want to do things interactive or do it through some kind of DevOps tool, all the DevOps tools have connections for Pulsar. Very easy for you to do different things there. We mentioned that multiple protocols. So you've got a lot of different options on how you connect to it. This is nice because, in most infrastructure you have out there, you can't just go, let me throw away every messaging system I have, all 6 of them tomorrow, and just start doing Pulsar. Maybe that's something you could do, but any organization I've worked at, when you get something new, it just gets added to it and maybe you slowly move over. Pulsar is perfect for that because I can add new stuff easily with the native libraries, but then I could slowly move over some of those existing apps because I've got adapters for them. So if they use JMS, I could do JMS for them. I could look like Kafka for them. I could look like MQTT. I could give them a REST endpoint. I can give them a web service endpoint. Lots of different ways to get them data to and from without you having to rewrite or rebuild all these existing apps, which is pretty cool. Pub sub, exactly what you think. Producers are making the messages, and subscribers can get the messages different ways. This is how we support messaging and streaming, depending on how you want to consume them. So that gives you that flexibility. You don't have to decide when you build the cluster. You don't have to decide when you build the topic how it's going to be consumed, other than if you're thinking about, do I need to partition topics or not? That's, some part of the thought structure there. Messages go through a single topic. They have a payload and they have some metadata around them. Pretty much the features you've seen in Kafka and other messaging systems. Pretty flexible there, what you put in and out. Brokers are the part that handles these connections and route messages. What's nice is they're separated from the storage. So if you choose, you can also make messages that don't have persistent durable storage. Maybe you just need them in memory. Maybe these are alerts or events that don't need to be stored within the broker. They just need to move as fast as possible. You could do that. Pretty straightforward. Lots of different things to do once you get something in a topic, which makes it pretty nice. Functions and connectors do things pretty lightweight in one of those languages we mentioned. And this will let you, stream data out of, your data warehouse, your cloud data lake, your lake house, whatever it is. We've got drivers for most of the things. And if not, most people will write them themselves pretty quickly. Connections to most of the things you want out of the box. Protocol handlers are also extensible. So if you have some other kind of messaging and you want to write an adapter, it is not rocket science. Pretty straightforward. We mentioned that we have the ability to do multi-tenancy, and it's very practical and obvious how to do it. You have, you set up different tenants, and these are created by creating a tenant, and it's let you name it however you want, logically separate it, and then underneath there, they could have as many namespaces as they want. What's nice here is I don't have to try to think of unique topic names, company-wide or, multi-company wide. I could break these up into different tenants. These could be different companies, or here you see different groups within a company, and then break them up to particular apps underneath. So you don't have to come up with some massively long topic name, makes it nice. And the theoretical limit for topics, no one's hit it yet. It is massive. I've seen tens of thousands, hundreds of thousands. You're limited by your imagination, use case, and how big of a cluster you're going to want to add. Again, extending a cluster, whether it's run through Kubernetes, run through Stream Native Cloud, or run through, Pulsar standalone, which could just run in Docker or your own bare metal or VM infrastructure. It's pretty easy. Things need more horsepower. You could add a broker in the front or add a bookkeeper in the back. Lots of different ways to expand these out pretty simply. The way we subscribe to the messages is really important because this decides, am I doing messaging? Am I doing streaming? Is it exclusive? I want a guaranteed order. Message comes in, gets produced, goes into a topic as a queue. One person's going to read it and it's in order. And I could do things like exactly once or at least once and set those things up. like you want to do in Spark or Flink processing. There's two of those, one exclusive, just send it to this one consumer. The other is a failover. This is a nice feature where I do want one person to read it unless they're not available. I mean, to me, that's the logical one I'd pick. Always have that availability of that backup there, so I don't have to worry about my processing stopped because somebody blew up. Shared is an interesting way of, I have something I want to use Pulsar as a work queue. I want to distribute microservices. Messages come in, have as many people out there consuming it as they want. Just process it. I don't care about order. Whatever message I get, run it, do something to it, go on. Could be calculations, could be storage, whatever it happens to be. And then some people are like, well, I like the first one, but my use case is closer to the middle one. What do you got? Key shared. I can have multiple consumers, but the difference is they're getting an ordered stream of them based on a key. And again, like Kafka and other messaging systems, messages can have a unique key with them. And this makes this possible for us to do these ordered for a certain key and keep those keys together for different consumers. Gives you a different option for doing kind of a hybrid streaming messaging approach, which is kind of cool. We mentioned that multi-tiers. What's nice, you don't really have to think about this. Either Kubernetes, Stream Cloud, or whoever you want can do it for you. Load balancers can be added or built in. Same with proxies. It depends on your protocol you're using. The brokers there are getting these messages. Things are stored and use metadata for Zookeeper. Again, like everywhere else, there's thought of maybe removing Zookeeper, and that's slowly happening in nearby releases. But it is a very stable way to do it, and it's set up pretty easily for you. But having that stateless serving, there's cache, but the state isn't stored there. State is stored in the bookkeeper knows, and then, tiered out to cloud and HDFS or whatever you have there. Gives you a bunch of different ways to talk to Pulsar, whether it's through connectors, through the PubSub API, through a reader or batch API, depending on the type of apps you're doing. Gives you a lot of flexibility there. There's a lot of different syncs out there, different connectors. We have them, most of them documented in the hub. Those are ones that have been tested, that we've done with a number of customers and people in the community. It's a great way to try them out. And again, these are all open source, many of them contributed by the creator of the source or sync, and there's really good ones out there for Aerospike, InfluxDB, ClickHouse, S3, Redis, all MongoDB, all the fun things out there. Pretty easy to run, simple configuration, and they just stream, the data right to it. Makes it very easy if you want to just take messages from any system you have, logs, whatever it may be, IoT data, and just have it go somewhere and not have to think about it. Very easy way to do that. We mentioned those different protocol adapters. There's an open API there. Some of the examples are things like AMQP, and they can be a source or a sync as well. So, I could use an adapter so Pulsar looks like AMQP, or I can have people push to Pulsar and Pulsar stream it to AMQP server for you, or in reverse, AMQP can be pulled in by Pulsar. Gives you a lot of options on how you integrate with other messaging systems. This is the real world. You're going to have a lot of them. Maybe someone you acquire, a partner. You're never going to have just one messaging system or one source or sync. It'd be nice to have just one database and just one messaging system, but if you're more than a one-person company, that's unlikely. There's a nice offloader for Azure, again, built into the open source. So the tiered storage is there, automatically connects there for you, depending on how you want to do that. Lots of syncs out there, whether it's for doing things like Lambda or connected to different cloud storage. You could take a look on some of those. There's another feature I think I touched on in the beginning, which is kind of cool. Thanks to the Presto project, which is an awesome way to query data. You can enable that for your Pulsar cluster in the open source by just starting a Presto Trino SQL worker, and that knows how to communicate with the bookkeeper nodes and their tiered storage. So at any point you have messages in the queue, and again, because of that durability, you can keep every message that ever entered the queue, and this will let you query it as if it was just a regular table. And Pulsar SQL has a nice way to be able to do this, and because it's just Presto Trino, you could use those drivers within, DB Beaver, any JDBC tool, NiFi, whatever you want, and just use that SQL to query any of these topics. And it just looks like a table. Makes it very easy for you to be able to get to your data while it's in stream or while it's just sitting in a topic, so that data is never lost. Another way to access that data, gives you a nice way to interface with how messages come through the system, and as far back as you want. So, a message doesn't have to live just temporarily. This lets you do sort of different architecture where the data is continuously streaming, and as those events happen, process them right away. But everything that's happened in the past, I could just query right from Pulsar. I don't have to set up another database if I don't want to. And the SQL is what you expect built into the box. We've got the Presto command line, so you can easily interface with that, so you don't have to use some other tool. And it's broken up into, tenants and namespaces, just like it is in Pulsar. You don't have to worry about it being a different paradigm. We mentioned MQTT. I like this one a lot because in IoT and a lot of events, they're natively talking MQTT. It's nice not having to run an extra broker or, have to worry about how do I get MQTT data from different devices into Pulsar cluster so I could use it somewhere. It's handled for you. And the terms there, you see, it's the exact same way we do all the parsing. So it's not, some half-done bolt-on add-on. It's not some proprietary bit you've got to pay for out of the box in the open source. Use that MQTT and it plugs in. You turn it on if you want. You don't turn it on if you don't want. You can make the that features available, and then it just works. What's nice is if I push a message through an MQTT publisher, it just becomes a Pulsar message. It doesn't matter. If I want to use any of the native features or the syncs, they just work. So you don't have to use the same mechanism in or out. I can publish from Pulsar, read it from MQTT, publish it from MQTT, read it from a WebSocket. Once it's a message, it's a message. Same for Kafka. Kafka library's got some new features coming out. Again, things are pretty full featured. If you try it out and you're missing a feature, put out a Jira out there. Always, adding new features here, but it's pretty strong support there. I mean, you could use pretty much all the Kafka libraries, Kafka Connect, all those sort of things. Geo Replication can be in any direction you want, active, done asynchronously. Obviously, real world, the further apart your data centers or clouds are, the size of that pipe's going to indicate if there's lag or latency there. But this is handled for you. You don't have to really think about it other than who's going to be connecting to who. This also gives you not just between data centers. Maybe I have a local gateway sitting in a store or in an ATM. We can Pulsar scales down pretty small. I've got it running on some NVIDIA devices on my desk. I can run a small cluster there, maybe standalone, just one broker getting the data and streaming it out, and then maybe talking to an edge gateway or an edge little server. Depends on how you want to do it. Very easy to use the native pub sub libraries or just use the Geo Replication. Depends what's easy for you. I love this this cartoon someone put out just to give you an idea how the scaling works. Because of that separation of compute and storage, if things start slowing down, add another bookkeeper node and things will be automatically start spreading out. You don't have to do any rebalancing. You don't have to point things to different things. The bookkeeper storage layer is behind the scenes. No client ever connects to it other than admin tools or the brokers themselves. You don't have to think about it. Add more nodes, scale out the back end. If you're not able to process the messages fast enough, scale up the front end. I mean, there's a reason why the cloud works that way. It's a good paradigm. Now, maybe you don't want to run open source on your own. Maybe you want to be able to call someone up, go on Slack and go, hey, Tim, check this out. It's too slow or something's not working. Stream Native Cloud makes it pretty easy. We run cloud native on most of the clouds, Kubernetes runners, and we include Flink SQL, which is really cool. We won an award. It's a pretty cool project. You know, give it a try out. We've got free trials and all that sort of fun stuff there. Now, if you've seen me before, you might have seen, I might have mentioned this project before, Apache NiFi. It's a pretty interesting open source project. That is a 12-foot skeleton that's still outside. I'm going to put a Santa hat on him in a couple of weeks. NiFi, kind of interesting tool. I know I'm probably taking too long here, so I'm going to move through pretty quick. This is a project that lets you easily graphically move data around. This plus Pulsar is kind of like superpowers because NiFi is good at grabbing weird sources of data, you know, setting up a graphical way to move through a couple different data while having that guaranteed delivery there and data buffering and provenance, all those things that make it easy to be able to develop apps at scale, data engineering, data pipelines, and connect to a lot of things. You know, if I don't see a connector in Pulsar, I could use one of NiFi's and, you know, mix and match how I connect data from point A to point B, or 400 points on one side, 200 on the other, all different places, types, pretty easy. NiFi also has a classic architecture for scaling, scales out very easily. There's Kubernetes runners out there, Docker, all those sort of things. However you want to run this, or you can run a single node. I run a single node on a device that's also running sensors and also running Pulsar. It goes down pretty small, very durable, nice way to do things. It has some feature I think is pretty awesome, especially you're in distributed processing. How do I know what's going on? It keeps a provenance or a lineage of everything going on. And that's configurable how long you keep it. That is available via REST API, available via command line, and available visually within the tool. So I could see what happened. You know, an event comes in, I want to quick trace that. I want to figure out what's going on. Got a unique ID there. I could see everything as it comes through the whole system. It's a good way to audit. I could have this all stored in an audit log. Someone says, where did this data come from? I could give you the lineage of that. Pretty nice. I could also do things like set up back pressure because sometimes downstream systems are offline or slow. This could have built-in back pressure for that. Can also prioritize data. Sometimes alerts come in. They need to come in faster than a regular message stream. Pretty easy. Records are a superpower. I could just look at data of any type and be able to query it while it's being processed, do transformation on it, and never know the fields. I could use schemas. I could automatically infer them. Pretty nice way to do it. Make it very easy to convert from XML to JSON or into Parquet, into whatever format you have there pretty easily. Read logs as if there was SQL. Pretty nice. Lots of different processors out there, as you can see. Again, open source and extensible. Add your own. In the last couple of versions, they added one that lets me decide how which type of data it is, so you don't have to hard code it. So, you know, as data comes in, I could either pass an attribute or determine that by looking at the data and say, oh, okay, data coming in is XML, use the XML reader, use the JSON reader, use a Parquet reader. Oh, what do I want it to look like? I don't even have to have that hard coded. I can look at some of the metadata and decide, oh, the person who sent this in wants this as Parquet. Okay, convert it to Parquet. Nice feature there. Again, Consume an MQTT built into as one of the components of NiFi. So I could use this to read from Pulsar. NiFi also supports native deep learning through DJLI. If you haven't seen this project, it's pretty awesome. It is a Java native way to do deep learning, and it has connectors to connect to any type of deep learning. So you don't really have to, stick to one. I can use this to connect to MXNet, PyTorch, TensorFlow, Onyx, ton of different ways to do it in a very clean, separated way. And it runs on multiple platforms, scales out really nice, and it plugs into NiFi. NiFi is extensible by custom processors, just written in Java. You could just drop in any existing component you have. Again, a similar feature that Pulsar has with functions. I'm in the middle of moving some of these over to Pulsar. So you can have multiple ways where I run my deep learning. Is it at the edge? Is it in the NiFi part? Is it in Pulsar? Is it in Pulsar locally at the edge at different parts of the cloud? You've got decisions where you want to move that. I mentioned Flink before. I want to touch on that one really quick. The reason I love Flink, besides the scalability, is a really rich SQL API. Now, I mentioned that Pulsar SQL. That's data as it is right now. I look at the data, get a result. It's done. It's query. What's different with this is queries on streams. So this continues to run. I write a SQL, a new event comes in, the SQL runs against it and get a result. And that result could just be displayed in a dashboard, but it can go to another topic. It can go to a data store. So now you've got a way to run things like this queries. The SQL support is really rich, and you could do some things that you can only do on streams of data. I could have windows of data that I'm looking at for various intervals, and I could do averages, sums, all these sort of things to do alert processing on my data without having to write complex code. Just writing some pretty straightforward SQL, have that deployed as a Flink SQL app and Stream Native Cloud or Vivarica or wherever you might be running, or in the open source on your own. And it just runs against your data streams as the data comes through. A nice way to write distributed apps without having to write complex Java or Scala or have to deploy it. SQL, pretty standard there. We've been working with the Flink community for a while. There was an official announcement of this connector recently in a recent version of Flink. So you can have connectors for sources and syncs, get things in and out of topics. Like I said, the easiest for me is, just being able to SQL against Flink and get the results back and, join together topics of live data. And for Flink, it just looks like a catalog of tables, which is pretty awesome. And then, it just has with what we have, one log in there, so you don't have to worry about managing that. And then just stream your data wherever it needs to go. It's a pretty cool way to write continuous apps. We have it in Stream Native Cloud, pretty straightforward. You just see, again, those tenants, namespace, and tables there. Tables are a topic. Obviously, someone's got to define a schema somewhere. If you're sending in a bytes of data with no schema, you have a problem. Fortunately, Pulsar has a built-in schema registry. You don't have to get some other component or how to figure out how to do that. It's built in there for you, and it supports the different schema types that you expect it to support and versioning, all that sort of stuff, but built into the project. Examples of using Pulsar. You might have lots of different microservices out there. What's nice is one tool set. So the people doing front end orders or back end processing, or people doing, your streaming analytics with Flink, use the same Pulsar topics. Different ways you might be interacting, different libraries, but that one set of data, one set of truth, one unified storage. And again, that can connect via Pulsar or Flink to tiered storage. So you don't have to try to manage different copies of the data. You got one source of truth there. Makes it easy to exchange data. and use that native tiered storage that extends out very well. And some of these e-commerce applications in the real world are scaling out to some of the largest possible. I mean, we're not talking a store that sells 5 t-shirts here. These are some large t-shirts. For my examples and demos, this is my common infrastructure. Got a lot of edge nodes over here, literally right here. And, I've had them for a while. Some of them were talking to NiFi. Some of them were talking to Kafka. Some were talking to MQTT. Some had HTTP WebSockets. Well, very easy just to point them to the Pulsar cluster. I've got some pushing through WebSockets, because that's the library I had available on that device. Some devices I can't really change the driver, or their architecture doesn't support driver 1 or 2 or whatever. There's a protocol somewhere that makes it easy for me. Gets it into Pulsar, and very easy to run that on Stream Native Cloud, but also in open source, I could just spin up one in Kubernetes or Docker or in VMs or bare metal very easily. Out of the box, type Pulsar, standalone, start, boom, ready to go. It'll run everything for you and scale out pretty well. You turn off storage offloading to the tiered storage, and you have that batch and stream together. And you can also connect it to Flink, whether natively on Stream Native Cloud or in your own infrastructure. Makes it easy so you don't have to worry about how I unite batch and streaming. And then obviously you'll want to make data available to things. WebSocket interface to Pulsar, I'll show you an example of that. Really simple. I have syncs published to a lot of cool data stores. If I don't see one I like, I could just use NiFi there. Pretty easy. Let's get into a demo before I waste all your time looking at slides. Let me quickly go through a couple things here. Just to show you real quick, I'm not going to harp on it. This is a nice interface with Stream Native Cloud to look at my data. This is some of the messages as you see in this format. I chose JSON, could have been Avro, could have been binary. Lots of different options there. Pretty easy for you to navigate your data and see the metadata you have. I manually added these as extra properties. Pretty easy. If you have questions, please ask them now. I'll try to keep an eye on the system here. Make sure we're, if you have questions, please ask them. I'm going to go through the demo, but if you have a question, rather handle that first. To me, that's of clear importance. So if you have any questions, please feel free to go through them. It's not a problem there. Just type them over in the chat, and I should be able to see them as we go through the system. So this is one way to do it. I like this. It makes it a little easier for you to see what's going on. Pulsar has great command line tools and REST interface to get through all this data. It's nice having a dashboard. There's also a number of free dashboards out there. Different managers makes it pretty easy. This is a connection to the schema registry here. And you can see this schema happens to be JSON. And it's pretty standard, the fields and such. I didn't have to build this schema. I wrote a Java app, put a Java class there. This did it for me. Code is pretty simple. I've got it in GitHub, so you can see how that goes. You can see the different policies for security, who has permissions. Very easy to add your authorization. You'll look at the storage behind the scenes, how this is managed, or just see what's going on with my system. Pretty easy. Now I've got an app here that I use for meetups. This is a very simple single page web app. What you're seeing down here is the data that I have already in my topic there. The web page is just doing a WebSocket call. Again, very easy to do. Just putting a message here, website. And I send it in, and there's down here. That went to Pulsar through WebSockets, went into a topic, and then my listener, web stream listener is just getting new messages as they come here. and they parse them. I put them in a box. Obviously you could think of more advanced apps you could write than my simple display one. You could put it in a notebook. You can put it in a dashboard. Very easy for you to be able to distribute data between components, live chat, or I just want to store it somewhere. Easily, this streams out to a table. I do that here. I could also just use it as a receiver of data. As data is produced, I could just have it here. Very easy for you to connect to anything that does WebSockets. I could also stream that to a data store, no problem, regardless of if it's something like a cloud hosted Postgres, whoever has a driver. And I can also connect with, I mentioned Apache NiFi, acts as another gateway there, makes it very easy for me to do that. Not the hardest thing in the world to be able to do that. If you have any questions, put them in there. I'm not seeing any yet. So I'm just going to show you some more of the demo here. This one, I'm using NiFi to grab some REST data and process it. The things come in as JSON records. I don't know what they look like, but I know it has this path there. There's some like header data I don't care about and some set of data inside one JSON message. And I want to break those apart. So I pull those apart, again, keeping them as JSON. I add a couple of fields that I need for unique identifiers and timestamps. I break them into individual records here. As you see, I stopped my Pulsar producer, which is a recent driver that my friend David has updated for the latest versions and latest connections, however your login is. This is all that provenance and metadata I told you about. I could just start this now, and it's going to start sending messages to my local Pulsar for this particular channel. You can see here, persistent. This is my namespace. This is a default namespace that comes with it. Create as many as you want. Not a problem with your however many as you need there. And then there's the namespace, and there's my topic. Again, you can see you could have a large amount of these because it's pretty straightforward there. And then down here, you got some options how I want to route messages, what the key is to send it out, all those sort of things. Pretty straightforward. Even on a simple node here, I'm processing thousands of them. Consuming them is pretty much the same thing. I've got so many here, I'm going to have to resize my queue there. Consuming messages is really easy. I have a connection to my cluster, and pretty straightforward here. This is my local one that's running on that NVIDIA server. Well, I call it a server. It's a NVIDIA Xavier box about this big sitting next to me that can be used in edge devices. And there's a lot of options on how you connect to it. I can add pretty much any kind of connection there. And this is just my pool for doing it. Pretty straightforward, not the hardest thing in the world to do. Here I'm taking some weather forecasting data, pushing it to Pulsar, same idea here. Pretty easy to publish to Pulsar, or I could have used a native sync to do it, or source it, just pull it out of there. Very easy, drop it into some other data store. I've got repos out here with all the source code, how things work, answer all the questions of, how can I check my data, make sure it's coming in, all the command line interfaces you might need, all the ways to create tables. Again, Pulsar administration is easy. You may have different ways to log in. There's also some other really helpful clients out there. Stream Native has one that works specifically with its cloud. So you log in once, you don't have to worry about having the login. Pretty straightforward. Tons of different command line tools to connect here, to build topics, list topics, look at internal data. When I create syncs, I could easily redeploy them, start a new one, whatever makes sense there. Very easy to do. All that scripted for you. All that can be done also through things like Terraform and whatever other tools you have. I got examples of how to do the Pulsar SQL here. Pretty straightforward. When you have a schema, you could see how it creates all the fields. Pretty easy, and it's got some built-in fields that come from Pulsar that tell you things about those particular messages that may be important for you, like the message IDs, the ordering sequence, all those sort of things you might have. Those come in. So you've got the ones that are in your data and your payload, but also all those metadata ones are available for your queries as well. And you could also create the tables on your own if you wanted to, and it depending on how you are working with the system there, pretty easy. And you could do some example queries here, things like max, min, counts. You can kind of get the idea there. And you could do the same for different ones here. Pretty straightforward. I don't see any questions. I know we're getting close to time here, or we are at time. But I'm going to keep going till we get pulled out of here. Hopefully, this is useful. Again, writing Java data produce things to Pulsar, very simple. Simple API, you can integrate it with Spring or whatever else you're doing. This is an example in Java because that's my easiest language here. To get this JSON schema of something, you really just have to create a standard Java Bean, simple class with properties, get sets, pick your topic, put a name in there, put a timeout, send your message. Pretty straightforward. Pretty easy when that data comes back. Put it in the time. Oh, okay. We are out of time. Let me just get to my thank you. And if you have any questions later, I'll definitely be in the app, or you could see me on Twitter, LinkedIn, GitHub. Thanks for joining. I'll close it out there. Thanks for having me. This has been very cool.
Sorry.
And I'll stay in the app. Yeah. Ran out of time, man. That's what happens.
Sorry for the pressure, Tim.
No problem.
So we can still wait a few seconds to see if someone has a question. Even if you do not have a question now, but want to ask Tim something later, maybe they can ask you directly over Twitter or something.
Sure,
Tim.
sure.
So yes, please feel free to reach Tim on Twitter or any other place. And yeah, let's close up for a small break. Thank you very much for being with us, Tim. It was a pleasure.
Thank you.
See you again next year, maybe.
Hope so.
Thank
in
you.
person.
Yes, exactly. Thank you very much. Bye, everyone.